Welcome to the part 1 of training on Module B of the G.EN.ESI project. Module A of this video series gives you an introduction to the two fundamental concepts of eco-design, life cycle thinking and environmental assessment. Module B will provide you with a detailed procedure to model the product life cycle and perform an environmental assessment. The first part of Module B is concerned with the assessment of environmental impact and how it relates to product design. This video has been developed within the framework of the G.EN.ESI project, which aims to support the integration of eco-design within the design and development process through the development of a methodology and a software platform. The methodology is presented in Module C and the platform and tools in Module D. This research project started in 2012 and involved 8 partners, 3 from academia, University of Paris, University Polytechnica del Marche and Grenoble INP. 1 public institution, the ENEA, National Agency for New Technology, Energy and Sustainable Economic Development, and 4 industrial partners, Gonta Design, Sibu Environment, Faber and Bunge Vectron. It is co-financed by the European Commission. The first part of modeling the product life cycle for environmental assessment starts with the introduction of the notion of environmental impact. We will start with a detailed characterization of what an environmental impact is, and then we will see how we can quantify these impacts from a product design perspective. We have already introduced a definition of an environmental impact in Module A. An environmental impact is a change to the environment and to balance ecosystems. The change can be positive or negative. However, most industrial activities tend to have a negative impact on the environment. Planting trees can be seen as a positive impact on the environment because it will reduce the environmental impact of global warming. An environmental impact is evaluated in relation to an activity that is carried out by humans, such as the design stage, which leads to the creation of a new product. To create a new product, resources are required and a certain quantity of substances will be discharged into the environment, which generate pollution. The use of resources and creation of discharge are responsible for the change of the environment. They cause an environmental impact. Another definition relevant from the biological perspective on environmental impact is that an environmental impact is a consequence of the emission of a significant quantity of biological or physical agents into a stable ecosystem that will make it unstable. The ecosystem and environment impacted can be of several different types. It can be related to air, soil, or water. This can be further decomposed into subcategories such as seawater or river water that have different biological and physical properties and therefore different ecosystems. Environmental impact have different sources. Some impact are consequences of a natural phenomenon, like a volcano explosion. Others are anthropogenic, meaning that the agents that have disrupted the stable environment are generated by human activities, for example, industrial emissions. An environmental impact has a geographical and temporal scale. They can be either local or global, and short or long term. A local impact will disrupt the ecosystem directly where the emission occurs. A global impact is a phenomenon that impacts an ecosystem further away from the source of the emissions. For example, in the case of global warming, an emission of greenhouse gas in any location over the globe will have a consequence on the global ecosystem. In terms of time scale, a short-term impact is one that has consequences soon after the release of the emission to the environment. Contamination of water due to an accidental release of chemical will have a short-term effect, and as soon as the emissions are diluted, the effect decreases. Other emissions have long-term effect or will affect the ecosystem after the actual time of emission. Decrease of fertility of species is usually a long-term impact because the effect of the emission on reproduction is not visible in the population exposed to the contamination, but in the next generation of individuals. We are already experiencing the global and long-term impacts of global warming. Ozone depletion is also a global and long-term impact because whilst the main contributors to the phenomenon are no longer allowed on the market, the consequences of activity 20 years ago are still visible. Other environmental impacts are, for example, toxicity of air or acidification of soil. But in environmental assessment, we not only consider environmental impacts but also environmental indicators. We use indicators mainly to represent the consumption of resources. Raw material depletion and energy consumption are not environmental impacts per se, but they are related to extraction of natural resources for the realization of human activities, and will have negative consequences in the future. For example, raw material depletion reflects the overconsumption of non-renewable and renewable resources to some extent. The effect of such depletion is to reduce the ability of future generations to access those resources. In addition to the environmental indicators that describe the state of an environmental issue that is not a disruption of an ecosystem, environmental impacts are separated in two categories: the midpoint and the endpoint. The midpoint indicators, which are the most commonly used, evaluate the importance of the disruption to the balance of an ecosystem. Balance of the global climate for global warming, balance of the nutrient content for eutrophication, balance of damaging substance for toxicity. The endpoint indicators represent the consequences of an unbalanced ecosystem. They summarize all the damage that is being done to an area of protection. For the Eco Indicator 9.9, the area of protection are human health, ecosystem quality, and resources. Each area is being damaged by a combination of environmental impacts and indicators. This is ultimately the best way to assess the state of an ecosystem, but the uncertainty of the evaluation using these indicators is higher than with midpoints. This is why endpoints are used to a lesser extent. We have introduced the type of indicator you can use for assessing the potential damaging consequences of a product throughout its life cycle. By using several indicators, you can be confident of considering all the negative consequences that you might have on the specific environment. And by evaluating these indicators over the product life cycle, you can make sure that the improvement you are making on a specific phase is not lost by an impact transfer. The first part of Module B has introduced the type of indicators you can use for assessing the impacts on the environment throughout the product life cycle. Part 2 will provide you with a methodology to assess the different indicators over the product life cycle. Parts 3 and 4 will detail how to model specific part of the product life cycle.